Sketching the difference of two functions just means that we're subtracting one function from another to find a new function. So that word difference is really all about subtracting. And the process here is really very, very similar to what we've just seen when we're adding two functions. If you know the equation of both of the functions, you can just subtract using your algebraic methods and come up with the equation for the new function, which you might be able to graph using your own graphing skills. If you don't have the equation of either function and you've just got a sketch, then you can use those same ideas that we've already seen when we were adding the functions together. But the key idea here is that if we're subtracting one graph from the other, then we need to subtract the y values. So that's the key idea. Now, some of these considerations we've already discussed when looking at the sums, and some of them are the same, some are different. So one that's the same, I'm actually going to leap down to the bottom here. If either curve approaches plus or minus infinity, then our subtracted curve, or our h of x, also does. But if one is approaching infinity as the other approaches negative infinity, then the behaviour of y equals h of x may not actually be clear. So let's jot down that that is exactly the same as when adding. Alright, well, what's different? Well, we saw before that where one curve had a 0, the other curve, whatever that y value was what our summed function would be. But here, if we're subtracting some things, then it depends which one is the 0. Because if this one is 0, and we've got 0 minus g of x, then h of x is actually just going to be that negative g of x, whatever the y value was there. Whereas if the second thing is 0, then we're going to just get whatever that first thing was. So think it through each time, what am I subtracting from what? And keep it really clear in your mind so that you don't mess that up. Where the curves meet, h of x is going to have a 0. Now that's because if we've got two graphs, let's say we've got one here and we've got another one here. Now when we added curves before, we reasoned that our new summed curve would be twice that tall. But if we're taking them away and they're both the same height, then our new curve is going to actually have a 0 there because that height minus itself is 0. So that makes that point make sense. It also makes sense that if the curves are equidistant from the x-axis, in other words, if one is equally far down here as the other one is up here, then when we added those distances in the last lesson where we were summing the two products, we would say whatever that is plus the negative version of it was 0. But if we're subtracting, well, we have to be careful which one is which because it's going to make a difference. So either way, we're going to end up with our new curve having a y value that's either twice the height away, but it's either going to be up here or it's going to be down here, and you need to check which. And that makes sense because let's say this was, say, a height of 3, and down here we had minus 3. Well, if we were doing 3 minus negative 3, that's the same as 3 plus 3, we would get 6, and so our curve would be up here somewhere. Whereas if we had negative 3 minus 3, that would give us negative 6, and we'd know that we're down here. So again, just be really careful which curve you're taking away from which, and it should all be fairly straightforward. So let's have a go at this with a simple example where we're actually given both functions and we need to subtract one from the other to get our new function. What we can do here is literally just say, well, we need f of x, so h of x is going to have an equation. It will be f of x minus g of x. Now, I can already hear what you're thinking. Don't make a classic sign error here. We need to put brackets around the thing that we're subtracting so that we can get our signs right. So take your time so that you don't make a mistake. This is 3x plus 2 minus 1 times minus x is plus x, and minus 1 times minus 1 is plus 1. So now I can tidy up and say that we've got 4x plus 3. Now I can graph y equals 4x plus 3 quite easily using gradient intercept form. You could draw up a table of values, you could find the x and y intercept, and you could rule it up that way. So there's lots of ways you can graph this straight line. I'm going to say it's got a y-intercept of 3, and it's got a gradient of 4, which is quite steep, and just rough it in like this, and this will be y equals h of x, y equals h of x, and I can easily find this point down here by letting y equal 0, and saying that 4x will be negative 3, so x must be negative 3/4, dividing both sides by 4 there. So now I can label that point. So I've graphed y equals h of x, and I found the equation of it by carefully subtracting one function from the other, but notice my use of brackets, very important. Now the other skill that we need is to be able to sketch the difference of two functions when we haven't been given their equations and we're just working off a graph or a sketch. So I've gone ahead and sketched y equals f of x here and y equals g of x from the last example so that we can see what we would have done if we hadn't actually been given the equations and we just had the graphs to work on. Now, easy thing to do here is to just take a few points and line them up. Think about the logical shape of your new curve. Both of these are straight lines, so that it's likely that the new line is also going to be linear. Now, I'm just going to literally take a few points here. I've got the point 1, 4 on this graph, so I can see that f of x here is 4, and when x is 1, I can see that my other graph, g of x, is negative 2. So simply saying, what is 4 minus negative 2? 6. So I can tell that I need the point 1, 6 now for my new graph, which is the difference of these two. What about when x equals 0? Well, f of x, which is the one I need to start with, is 2, and I need to subtract negative 1. 2 minus negative 1 is 2 plus 1, and that's 3. So I can see that I need my y value of my new graph to be 3, so I can put a dot. What about when x is negative 1? Well, I've got f of x is negative 1, and I have to do negative 1 minus 0. So that's negative 1. So I can see that I can put a dot here too. And now then it's no surprise that these three dots are going to line up to make that same straight line that we just graphed when we did it from the equation. We can do the same thing just by looking at various key points here and joining them up with a logical shape. Now my sketch is pretty dodgy here because I don't actually have graph paper. Your sketch in your book should look a little bit nicer, and if you rule your lines with a ruler, it should make a lot more sense, I think. So pause the video now so that you can do a sketch that's similar to mine. Bit better, hopefully. Now let's have a go with some sketches where we don't actually know the equations of either of these functions. We need to do f of x minus g of x to come up with our new graph y equals h of x, which I'm going to do in red. So let's start with some key points here. We need to make sure we know what we're subtracting from what. At any value of x, you can almost imagine sort of putting a ruler on it and looking vertically. We want to do the y value of the parabola minus the y value of the line. So let's start with key points. How about we start here? Now the y value of the parabola and the line are exactly the same. So if we do one minus the other, we're going to get 0. So at that x value, I can see that it needs to sit right here. All right, what about over here on the y-axis itself? Well, the parabola is a fairly small positive number, and I'm subtracting this much bigger number. So if I have this, but I take away all of that, I'm going to end up, whatever that distance is, down below here. It's going to come somewhere around about like that. Now this is literally a visual arts technique here that you can use to line things up. I don't even have any numbers on my axes, and yet I can see that I need to do this y value, so start here, and subtract this y value. So take that length and drop it down below the point that you have. That's your new point. All right, what about over here? They're both meeting. That means their y values are the same. So when you subtract two numbers that are identical, you're going to get 0 again. Okay, so we've got that. All right, what's going to happen over here as we get really large positive numbers and we start to subtract a negative number? Well, subtracting a negative, once we're over this way, subtracting a negative is just adding a positive, isn't it? So that's going to make our graph very positive. It's going to be actually up close to this one, because we've got a huge positive number, and then we're adding another small but also positive number to it. What about in between here, when we've got a 0 on this graph? Well, that means that we're not taking anything away. So at this point here, probably I need to extend my parabola a little bit just so that it's a better question. Let's make it come up like this more, a little bit more slopey on the side here. Y equals f of x. Now I can see that where these line up, my new graph is going to go exactly through that point. And that's because I've got y equals f of x, whatever that height is, and I'm subtracting 0 from it. So I'm getting a point up here. So beyond that, we've already reasoned that we're going to be actually not subtracting anything, we're subtracting a negative, which is adding a positive. So our graph is going to go above the parabola. It's going to sit above on this side. And what sort of shape are we expecting here? If we've got a parabola and we're taking off something that's linear, we're probably going to end up with something that is also a parabola. So at this point, I can probably reason that I can start to join up my dots here and come up with something that seems likely. Now what's happening up here is that we've got a large positive number and then we're subtracting something that's also positive. So I guess we're going to have a positive number, but it's not going to be as massive. So we're sort of heading up like this somewhere, in some sort of way. So yeah, it's a rough sketch. In fact, now that I look at it front on, it's a little bit on the dodgy side, but mathematically it's got the right principles starting to happen here. Now bear in mind that in maths, a sketch is exactly that. It's a sketch. It can be a little bit on the wonky side, but it needs to have the right mathematical principles going on. It doesn't have to be artistically perfect, and it doesn't necessarily have to go through the exact points that a sketch would go through if you were to sketch it using graphing software or actually taking time to get every single point perfect. So don't be too precious about it, or you'll end up taking too long to do each one and you won't get enough practice to actually learn the skill.